We're now going to look at a new method of summation. This one's called the method of differences. Best way to show you this is to look at an example. Express 2 over r plus 2 as partial fractions. Well, I'm going to assume that you can all do partial fractions, and we can go straight to the answer of this bit. 2 over r plus 2 is equal to 1 over r minus 1 over r plus 2. Now, the method of differences says to go through, put r equal to 1, put r equal to 2, put r equal to 3. If we put r equal to 1, we get 1 over 1 times 3, r equal to 2, the next term, r equal to 3, r equal to 4, r equal to n. It's well worth writing out a long table till you see a pattern which is going to help you. So the first thing we're going to look at is r equals 1. That gives us, on the left-hand side, 2 over 1 times 3 is, now don't be in too much of a hurry to do things, minus 1, yes, I'll allow you to add. 1 plus 2 is 3. R equals 2. On the left-hand side, I get 2 over r is 2, 2 times 4. Put r equal to 2. 2 plus 2 is 4. Keep your eyes open while you're doing this to see if you can see anything which helps. R equals 3. 2 over 3 times 5 is 1 over r is 1 over 3 minus 1 over r plus 2 is 1 over 5. Can you see anything which helps there? There is something which helps. Always be prepared to do another line or two if you can't see what's happening. Put r equal to 4. 1 over 4 minus 1 over 6. Remember that we want to add these lines up. So we're going to add everything up. You've got 1 minus 1 over 3, 1 over 2 minus 1 over 4, 1 over 3 minus 1 over 5. Did you remember that I said minus 1 over 3? Oh, 1 over 3 minus 1 over 3 is going to disappear. 1 over 4 minus 1 over 4 is going to disappear. 1 over 5, if I wrote it down, is going to disappear. 1 over 6. We can see a lot of things are going to disappear on this. So 1 over 3 minus 1 over 3 disappears with 1 over 3. Minus 1 over 4 disappears with 1 over 4. Minus 1 over 5 will disappear with the next one down, and so on. So we can see that quite a lot of this disappears, and all that we're left with at the top is 1 over 1 plus 1 over 2. Well, we need to see what happens at the end of this table. So let's go down to r equals n minus 1. This will give me 2 over n minus 1. That should have been a 6. 2 over n minus 1, n plus 1 is 1 over n minus 1 minus 1 over n plus 1. Same pattern. R equals n. 2 over n plus 2 is 1 over n minus 1 over n plus 2. Now, what will have disappeared? The 1 over n will have disappeared with something up there. The 1 over n minus 1 will have gone as well. The 1 over 6 will have gone. And so when we come to add this up, adding up the left-hand side gives me what I'm looking for, nearly, sigma 2 over r plus 1, from 1 to n. And on the right-hand side, at the top, we've got 1 plus a half, that's 3 over 2. And at the bottom on the other side, we've got minus 1 over n plus 1 minus 1 over n plus 2. Okay, we just need to sort that out now. A little bit of algebra. Put it all over 2 n plus 1 n plus 2. I'll have 3 n plus 1 n plus 2. Minus, cancelling the n plus 1, I'll get 2 n plus 2 minus 2 n plus 1. Then it's just a piece of algebra, and we get, multiplying out the first bracket, 3n squared plus 3n, that's plus 9n, plus 2, that's plus 6, minus 2n minus 4, minus 2n minus 2, all over the same thing, 2n plus 1, n plus 2. On the top, I've got 3n squared. 9n minus 2n minus 2n is 5n. Plus 6 minus 4 minus 2, there you go. 2n plus 1, n plus 2. That's a rather nice little technique. I like it. The examiners quite like it. And the examiners, unfortunately, have a little habit of doing this. Notice the 2. The question just had a 1. So in order to answer the question, I now need to divide everything by 2. (3n squared plus 5n dividing by 2 gives me 4n plus 1, n plus 2. Very nice, very easy, very, very easy to fall into Mr. Examiner's trap, and you end up not dividing by 2. Sometimes you have to look a little bit harder to find the terms which cancel. Another example, very similar in many ways. Partial fractions first, then something nice will happen if you put r equal to 1, r equal to 2, r equal to 3. So first of all, let's assume that you can do partial fractions. 3r plus 4 divided by r plus 1, r plus 2 is equal to 2 over r minus 1 over r plus 1 minus 1 over r plus 2. Right. We want to add up all the terms on, lost it, there we are. We want to add up all these terms, putting r equal to 1, then r equal to 2, then r equal to 3. So don't be tempted to take shortcuts. R equals 1. On this side, we've got 3 times 1 plus 4 over r plus 1, r plus 2. That's 1 times 2 times 3. This is where it seems a little bit pedantic, but I write it like this for a purpose. 2 over 1 minus 1 over 2 minus 1 over 3. You won't see any patterns yet. R equals 2. 3 times 2 plus 4 over 2 times 3 times 4. 2 over 1 minus 2 plus 1 is a 3, and 2 plus 2 is 4. Don't do the sort of cancellation type of work. Sorry, I should have written 2 over 2. 2 over 2, don't cancel that down as 1. Leave it as 2 over 2, and so on extra lines coming up. R equals 3. 3 times 3 plus 4 over 3 times 4 times 5 is 2 over 3 minus 1 over 4 minus 1 over 5. Put r equal to 4. Can anyone see anything yet? If you have seen something, I think you should go on to the next line to make sure the pattern you've seen actually works. 3 times 4 plus 4 all over 4 times 5 times 6. 2 over r, that's 2 over 4, minus 1 over r plus 1, that's 1 over 5, minus 1 over r plus 2, that's 1 over 6. Have a look at that. Can you see something nice happening? Well, this is why I don't like you cancelling that down. Let's just look on the line above. I've got 2/3. Take away 1/3, take away 1/3. They're disappearing. 2/4, take away 1/4, take away 1/4. They're disappearing. That's why it's nicer to see 2 over 4 than 1 over 2. 2/5, take away a fifth, take away a fifth. So in this one, we have a pattern which is similar to the ones we've had. And we're losing them like that. 2 over 4 minus 1 over 4 minus 1 over 4. And the same is going to happen with the fifths and the sixths. So now we must look at the last lines and see what's going on then. So let's go down. Let's look at r equals n minus 1. I'll have 3 times n minus 1 plus 4 divided by n minus 1 n plus 1. That's into the formula which is just now come back at the top. That's 2 over n minus 1 minus 1 over n minus 1 over n plus 1. And if we put r equal to n, we get 3n plus 4 divided by n times n plus 1 times n plus 2. That's going to be 2 over n minus 1 over n plus 1 minus 1 over n plus 2. Now we want to add them up. Well, adding them up on the left-hand side, I've got what I'm looking for, the summation, r plus 4, r plus 1, r plus 2 from 1 to n. On the right-hand side, I need to look and see what I've got. At the top, the ones that I haven't used are 2 minus a half plus 1. So that's 5 over 2. 2 plus 1 is 3 minus half, 2.5. So I have 5 over 2. On the bottom, the 2 over n will have gone with the 1 over n and a 1 over n before, and everything else will have disappeared. So I'm left with minus 1 over n plus 1, minus 1 over n plus 1. That's minus 2 over n plus 1. And then the term in the bottom corner, minus 1 over n plus 2. Now it's just a piece of algebra again. Put them all over the same denominator, 2, n plus 1, n plus 2. I'll have 5, n plus 1, n plus 2, minus 2 times 2, n plus 2, minus 2 times n plus 1. Sort that out, and we get 5n squared plus 3n is plus 15n plus 2 times 5 is plus 10, minus 4n minus 4 minus 2n minus 2 all over 2n plus 1, n plus 2. Top line, the 5n squared sits as it is. 15n, take away 4n, take away 2n is 9n. 10 minus, and I've made a mistake, that 4 came from, well, it didn't because it shouldn't have done. 2 times 2 times 2 is 8. Well, it's just like a normal lesson, isn't it? So you have 10 minus 8 minus 2 is 0. It disappears. And we have that all over 2n plus 1, n plus 2. So that is the method of differences. You really should, every time, take the long route. Don't try and take shortcuts. Some of you, I'm sure, who are watching this didn't spot that. Once you've seen the sort of thing you're looking for, you know what's possible. It's more difficult if you write that as a half to notice it. Okay.